Hello, welcome to the video, everyone. Evaluating limits is a very important concept to learn when practicing calculus. So let's jump right in. As you can see here, we have function x squared. We have it graphed here. It's continuous, which is a good one to practice on. So here's a practice problem. Limit as x approaches 2. We can start at x equals 0 and gradually move towards 2. The function is going up as x approaches 2, and when x is 2, the function value is 4, and we're on the graph. So the limit as x approaches 2 would be 4. It doesn't ever reach 4 because it says x approaches 2, not x equals 2. Okay, we'll do another one. Limit as x approaches 1. Well, I don't have it marked here, but okay. As x is starting at 0, we're going to 1, and the function value is 1 at that point. Once again, this is continuous. The same is true if we start at 2 and we gradually go down to 1. We would move down the slope until we're at 1. Once again, we're not equaling 1, we're just approaching 1, getting closer and closer and closer until the limit would be 1. Okay, this is a more complex function. As you can see, it has a gap right there. So in this case, since the function is not continuous, we would have to use what's called a one-sided limit to check and see if the limit does in fact exist, which I'll go ahead and write that out here. So as the limit approaches a number, we'll call that a, from the left side, and it also approaches an x value we'll call a from the positive side. If these are not equal, then the limit does not exist. So we'll do limit as x approaches 3. At x equals 3, the function is continuous. We can draw without lifting our marker off the paper, so we don't have to check the left side and the right side for this particular problem because they're both going to be the same. So as x approaches 3, we can start from 4 here. We're gradually getting down, and here's 3. And here we can just estimate 3 1/4. So now we can check the limit as x approaches 1. Okay, so as x approaches 1, from the left side, we seem to be approaching 1. But from the right side, starting at 2, we're approaching 2. So that's a problem because we're reaching 2 different numbers. So we're going to need to check the left side, and we're going to need to check the right side. So as x approaches 1 from the left, it's approaching 1. As x approaches 1 from the right side, and going down the graph, we're reaching 2. We're approaching 2. Well, 1 is not equal to, so I'll write it up here. The limit as x approaches 1, D and E does not exist. Okay, so as you can see here, we have a function with an asymptote in the middle. The x values never quite equal 3. So we have a limit on the right, and we can take a limit on the left. The limit as x approaches 3 from the left, and the limit as x approaches 3 from the right. Well, what do we see here? As x approaches 3, and it's going up this graph as x approaches 3, well, it's approaching infinity. And the same thing for the right. As we start at like 5 or 6, and we get closer and closer to 3, we're traveling up this function, up to infinity. So therefore, the limit as x approaches 3 is infinity.